Guys, welcome to my YouTube channel. Please like, subscribe, comment, and share. So today we are doing advanced biology, the nervous system, the active potential. So let us start. During an experiment carried out by scientists to stimulate the axon to induce the electrical impulse. The purpose was to induce an electrical impulse. They got a result that the potential difference across the membrane changed. It actually rose from -70 millivolts to +40 millivolts. So we want to look at what really took place when this happened. How did the potential difference change? So action potential, this results in the change in polarity, as we have seen. So this is generated by a change in the sodium ion channels. So these sodium ion channels, they are gated, which means they can open and close. That that was explain the ratio of the permeability which we talked about in the series of resting potential. That the permeability rate is 1:20. This is for the potassium ions, and this is for the sodium ions. So this permeability is the one which is being talked about. It is due to the channels being gated. So in response to stimulus, sodium gates bring about a slight depolarization. Okay, and then sodium plus gates are sensitive to the depolarization. So greater depolarization, for, for the more the gates open. So we are seeing a stimulus bring about a depolarization of the sodium gates, and this triggers the sodium gates to open even more and more. So this is a positive feedback loop and occurs and results in explosive acceleration in the rate of sodium entry. So sodium and ions begin to enter into the axon at a very fast rate. This will happen in about 1,000th of a second. So during this depolarization of the axon membrane, the axon membrane causes potassium gates to open. So since the sodiums are moving in, the potassium needs to move out so that it goes back to the resting potential. So potassium ions diffuse out of the cell. So inside of the cell, this is to make inside of the cell less positive, or instead the process of repolarization, as we have said. So going on further, at the peak of the action potential, now sodium gets start to close again. So at the peak of the action and potential, the the sodium gates start to close on on their own, because the inside could have been very much more positive. So sodium permeability declines, and sodium potassium pump gradually begins to restore the original resting potential. So during this restoration of the resting potential, the the resting potential usually drops more than the minus 70 millivolts we know. So after draw, it can arrive to about minus 80 millivolts. So this is called a hyperpolarization, and it's due to the slow closing of the potassium gates compared to the sodium gates. Okay, so let us summarize the whole process with some diagrams. So here, let's start with this at the bottom here. This is our axon. We've just taken the axon part. This is the axon membrane. Also, this is the axon membrane. So here we see at the beginning, we see that there are positive charges at the outside and negative charges in the inside. So this is the resting potentials here of minus 70 millivolts. And then after a stimuli, we see that there start to be a depolarization of the membrane. Now the outside is becoming more negative and the inside is becoming more positive. So we want to see how this depolarization is brought about. So let us first label our graphs here. So we have this graph. We have permeability uh, of the sodium ions and permeability of the potassium ions. And here at on the blue graph at the peak, we have the action potential, and then here on this, on the line just above the line with the numbers on the blue graph, we have the resting potential. You can see it is at our minus 70 here. So now, when do we need to label anything? Okay, and then this is the hyperpolarization. When we go on to almost about minus 80 millivolts. So we want to talk how the depolarization is brought about. So before we go further, in this direction on the blue graph, this is the depolarization. And then the 4 of the graph is the repolarization. Right. So we want to see how this depolarization and repolarization is brought about. So let's go to the red graph. We have this graph of the sodium ions rising up. This means the permeability of the sodium ions has become more. The gates of the sodium ions has been opened. So since the gate has been opened of the sodium ions, we'll see at the blue graph that it will also start to rise because they are becoming more positive ions entering the into the axon. So when this happens up until we arrived at a potential difference of about plus 40 millivolts, that's where we have our action potential. So at this point, this is when you look at the red graph, we'll see that at the peak it reaches a certain peak and then start to fall. So we at this peak, the sodium ions, the gated channels of the sodium ions start to close on their own. So the their permeability will start to decline. So we also see on the blue graph that the the potential difference will start to decrease, going to repolarization again. However, this is here. The repolarization is also helped by the uh, potassium ions. uh, we see at this dotted red graph that just after the starting of the depolarization, the sodium ions start to increase in permeability. Now the sodium ions will be moving, the potassium ions, sorry, will be moving in the different direction, trying to maintain the resting potential. And then, so as we can see, the rise of this graph is the increase in the permeability of the potassium ions, and the decline of it is the decrease in the permeability. So the decrease is due to the repolarization taking place. So the gates which we have, the potassium gates which we have been opened, will start to be closing. So we have talked about hyperpolarization. So we say this is due to the potassium uh, gates closing very slowly. So this is why these graphs are closing at different positions. You can see this one is closing first and this one is closing at a later time. So yeah, this is our action potential. Thank you for watching.